All right, welcome back to the deep dive. Today we're going deep on something pretty important, the security of AI. And we're going to try and boil it down for you, make it so you walk away knowing the basics, but you're not overwhelmed with technical jargon.
Yeah, and we've got a few really interesting sources to pull from. We have this draft security framework from SANS, some observations of real-world threat activity from Google, and then a really cool hands-on course in, it's called Offensive Prompt Injection.
Oh, that sounds a little edgy.
Yeah, it is, and that's kind of the point. You want to understand how to defend against something, you got to understand how to attack it, right? So that's going to be fun. But I think the main goal today is to really help people secure their AI systems.
Yep. Actionable insights. That's what we're after.
Precisely.
Okay, so first things first. The world of AI security, it's not just about the technical bits anymore. It's getting much bigger than that.
Yeah, it's definitely expanding. The SANS draft, I think it reflects that shift pretty well. It's still rooted in technical controls, of course, but now they're really integrating governance and compliance. They're realizing securing AI, it's a much broader challenge for organizations.
That makes sense.
Yeah.
Look at what they're recommending. Managing the AI's context window, that's like its short-term memory. Then you've got AI bomb, the AI bill of materials, transparency for all those AI components. And, of course, there's a whole mess of navigating regulations like the EU AI Act.
And what really makes things interesting is the speed of it all. AI is just developing so fast. The landscape changes constantly. Even the SANS document itself calls that out with examples like DeepSeek's new chatbot and the U.S. Stargate AI project. It's relentless, this progress.
Okay, so let's break down the SANS draft a bit. They've got these fundamental control categories for AI security.
Right. They've identified, access controls, data protection, deployment strategies, inference security, monitoring, and then the GRC, governance, risk, and compliance. Those are the big ones they say we really need to focus on.
So access controls sounds pretty basic, right? But it gets pretty complex when you're talking about AI models and infrastructure.
Yeah, for sure. It's all about strong authentication, making sure you have really granular authorization, and then you got to have constant monitoring. Those are the things you need to protect your AI models and all the sensitive data they use. Literally, it's the keys to the kingdom.
Yeah. And they had that example in the SANS draft, the compromised auditor agent inside a generative LLM. Kind of scary when you think about it.
Right. It shows you how important trust is in these systems. There's something that's supposed to check if the AI's responses are okay. If that gets messed with, the whole system falls apart. Security is not just about keeping people out anymore. It's about keeping the inside safe, too.
So not just who can use the model, but protecting the model itself at its core.
Exactly. Protecting those model parameters, things like encrypting the model files when they're not in use, using runtime obfuscation so it's hard to reverse engineer. And then you've got trusted execution environments, those secure little areas inside processors. Those are all layers of defense. And I think the OWASP, the Open Web Application Security Project, they've got some good stuff on this too if people want to dig deeper.
It sounds like a lot more than just a password, that's for sure.
It is. And the whole zero trust thing, where you don't just trust any user or system automatically, that's super important for AI, especially because access can be from anywhere, any device, any app. It's all over the place.
Right, okay. Data protection. Everyone knows data is what makes AI work, but what are the security issues there?
Well, the biggest thing to understand is that an AI model is only as good as its data, right?
Yeah.
If the data used to train it is biased or messed with, the whole model will be too. And sometimes that's really subtle and hard to catch later on.
And that's where the SANS draft really stresses avoiding data commingling and the whole need to sanitize or anonymize sensitive data before you use it with LLMs.
Yeah.
Why is that such a big deal?
See, it's all about privacy and security coming together. You mix sensitive data from all these different places without the right controls. You're asking for trouble. Someone could figure out stuff they shouldn't. So things like differential privacy, that's where you add some noise to the data to protect people's info, kind of like what the Census Bureau does. It's essential.
And it's not just about the data that trains the models. It's also about the stuff we put in, the prompts.
Yeah, that's a good point. Prompts, they can be tricky. You might think you're just asking a simple question, but if someone malicious got a hold of all your prompts, they could figure out a lot about your business, your data, even people's personal info. It's all there, just waiting to be uncovered.
So the takeaway there is be careful what you put in those prompts. And definitely don't use them for confidential info, right? Okay, what about deployment strategies? That's about where we actually put these AI systems.
Yeah, and that's a big decision. You can host it yourself locally or use a cloud-based LLM service. Both have their pros and cons security-wise.
I guess local hosting gives you more control over the data, but you need the resources, the computers, the infrastructure. Cloud's easier, but you're trusting someone else with your data.
Exactly, and that's where vendor lock-in becomes a risk. You got to do your homework. When you're picking a cloud provider, really grill them on their data practices. What do they do with your data? How long do they keep it? What about logging and access controls? Get it all in writing in the contract. Who's responsible for what? Who owns the data? It's all important.
Sands also pointed out the risks with integrating AI into IDEs, those integrated development environments that programmers use.
Right, and it makes sense. These integrations are super useful. They can make developers way more efficient. But there's that risk of exposing your code, your algorithms, your models, your API keys. Everything's right there. If you can, stick to local-only LLM integrations, at least for now. It's just safer.
It sounds like trying to build access controls directly into the LLM itself is not the best way to go.
Yeah, it's tricky. There are other approaches, like RAG, Retrieval Augmented Generation. That's where the LLM uses an external knowledge base to answer your questions. Now, with a RAG, you can implement access control lists, or ACLs, at the level where the system retrieves the information. That way you're controlling who can see what right at the source. It's usually much more reliable than trying to handle permissions inside the LLM itself. Plus, it helps make sure the AI doesn't give you bogus information.
What about backdoors in AI models? That's something Sands mentioned, and it sounds a little unsettling, to be honest.
Yeah, that's a big concern, especially with models that come from, less than trustworthy sources. A backdoor, it's like a secret trigger. Someone could build it into the model so that when the AI sees a specific thing, it does something bad, something it's not supposed to do. And once a backdoor is in there, it's super hard to find and get rid of, even if you try to retrain the model.
So that's why it's so risky to just grab any old model off the internet, right? They don't know what could be lurking in there.
Exactly. It's like trusting a stranger with your house keys. Public models, they might have vulnerabilities nobody's found yet, or they could do things you'd never expect. That's why red teaming is so important. Actively trying to break into your own systems to see where the weaknesses are, and having an internal model garden where you keep a collection of models you've vetted really carefully. That's a good idea too.
All right, let's move on to inference security. What is that exactly?
Well, it's all about making sure your AI model, once it's up and running, does what it's supposed to do and doesn't get manipulated to do something harmful or misleading. You're protecting the model while it's working, basically.
So LLM guardrails are important here, right? Those are the rules that control what the model can and can't say.
Yeah, and it's interesting how different those guardrails can be. Some are just basic keyword filtering or rules someone set up manually. Then you have the fancy built-in stuff from the big LLM providers like AWS Bedrock, Azure AI, and Vertex AI. They're always working on new ways to keep the models in check. Some even use another LLM to watch what the first one is doing.
But Sanez says you shouldn't rely on guardrails alone.
Yeah, because people who want to break the rules, they're always finding new ways to do it. Attackers are clever. For really important stuff, sensitive info or actions you absolutely don't want the AI to do, the best thing is to make sure the model can't even access that stuff in the first place.
So it comes back to that sanitizing and validating, both what goes in, the prompts, and what comes out, the responses.
Right, and prompt injection is a big one here. That's where someone sneaks bad instructions into the prompt you give the AI. They can do it directly, just put the bad code right in there, or indirectly by hiding it in something the AI is supposed to read, like a document in an RG system. The whole point is to trick the AI into doing something it shouldn't.
And all this gets even more complicated with multimodal AI. The systems that can handle text, images, audio, all that.
Right. And one thing we're learning is that the safety mechanisms might not be equally good across all those different modes. Like something that's blocked in text might slip through as an image. That's a big concern.
What about multilingual models? Do they create new vulnerabilities?
They can. You see, when you train a model on multiple languages, it's great in a lot of ways. But often the safety stuff, the filters and guardrails, they're best at English because that's what they were mainly trained on. So people have found ways to bypass those filters by using other languages. And it's not just languages, it's different character sets, even weird Unicode characters. It's all about finding the loopholes.
It sounds like attackers are even using encoding and compression to try and sneak stuff past the defenses.
Oh yeah. A lot of models can handle different encoding schemes, like base 64, hexadecimal, Morse code, and they don't always need to be told what format it's in. So attackers can hide their malicious code that way and make it look like gibberish. And compression, it's the same idea, squeeze the data down to make it harder to detect.
So for any LLM that's used internally or for anything sensitive, authentication and access control are super important.
Absolutely. Public chatbots, maybe you don't need authentication, but anything internal, anything important, you gotta lock it down. Leaving your API or your user interface wide open, that's just asking for trouble.
All right, let's talk about monitoring. It's not just a set and forget it thing, right?
Yeah.
You got to keep an eye on these AI systems.
Right. You need continuous monitoring to catch any problems early on, whether it's the model's performance dropping, someone trying to attack it, or someone accessing stuff they shouldn't. You need to know about it. So logging everything, having systems that can spot unusual activity, and then drift monitoring, that's where you track how the model's behavior changes over time. That's all essential.
Okay, last but not least, we've got GRC, governance, risk, compliance. That's the big picture stuff, right?
Yeah, it's about making sure your AI stuff is done right, responsibly. You gotta follow the rules, make decisions based on the risks involved. That means doing proper AI risk management, keeping track of all your models in a registry, having a good AI bomb, and making sure you're following the law, which keeps changing all the time.
And SANS recommends integrating AI monitoring into your existing security policies. And they really stressed protecting the audit logs.
Yeah, because those logs, they can have a lot of sensitive stuff in them about how the AI is being used, any security incidents, all that. So keeping them safe is crucial. And it's a good idea to have a dedicated AI GRC board, or at least make sure AI is part of your regular GRC activities. That way you can address everyone's concerns and set clear rules for how AI is used.
They also mentioned things like making sure the models are reproducible, storing all the model artifacts securely, and integrating security checks into the CI/CD pipeline.
Right. That's all about making sure you're deploying your AI models in a consistent and secure way. No one's messing with them without permission, and you're automatically checking for security issues throughout the whole development process.
And the laws, the regulations, it's a bit of a jungle out there, right?
Oh, it's a mess. Every region is doing its own thing. You've got the EU AI Act, which is all about classifying AI based on risk. Then you've got the LLMs Act in the US, which is about stopping people from using AI to fake voices without permission. And then there's the US National Policy, which is more general guidelines. The Council of Europe is focused on human rights, China on socialist values, Israel has a sector-specific approach, California wants to make sure powerful AI models are safe, and Utah is all about who's liable if generative AI messes up. It's a lot to keep track of.
Okay, that was a great overview of the SANS draft.
Oh,
Let's get real world here. How are actual bad guys using AI? Google just released a report on how people are misusing their Gemini model.
yeah, and that's a real insight into what's happening out there. But the good news is, it seems like right now they're mostly using AI to make their current work easier, not to come up with brand new attacks.
So things like research, troubleshooting code, and creating and translating content.
Right. And it's interesting, the Iranian APT actors, the Advanced Persistent Threat Groups, they were the ones using Gemini the most for all sorts of things. Russian APT actors, they weren't using it as much, at least during the time of the report.
It's good to know that Gemini's safety features actually worked. You know, they stopped people from getting content that could be used for really bad stuff.
Yeah, that's reassuring. The help Gemini provided was mostly for normal stuff, like writing text, summarizing info, explaining complex topics, and basic coding. Anything shady got blocked by the safety filters.
And it seems the bad guys weren't very good at getting around those filters.
Yeah, the jailbreak attempts they saw were pretty basic, and none of them worked. Like trying to get Gemini to write ransomware or DDoS tools, stuff like that, the filters caught it all.
So what were these government-backed groups using Gemini for specifically?
Well, they used it for coding, vulnerability research, general intel gathering, looking for targets, and even doing stuff inside networks they had already compromised.
What kind of targets were they interested in?
The Iranians, they were looking at defense organizations, military stuff, IT providers, and they were especially interested in anything related to the Israel-Iran conflict. North Korea, they were researching companies in all sorts of sectors, U.S. military in South Korea, even free web hosting providers. And the Chinese, they focused on the U.S. military and IT companies in the U.S., trying to find out about databases of U.S. intelligence people and target specific network ranges.
What about the coding? What were they using Gemini for there?
Some tried to use it to sign malicious Outlook plugins, those VSTO things. Others were trying to add self-signed certificates to Active Directory or researching Mimikatz, which is a tool for stealing Windows login credentials. And some were even trying to write basic code to record from webcams.
It sounds like that Iranian group, APT-42, they were really into phishing.
Yeah, big time. They use Gemini a lot to find out about policy experts and defense organizations. Then they'd use it to write phishing emails and even translate them into different languages, even tailoring the language to specific people within a U.S. defense organization. It's pretty sophisticated.
What about the groups backed by China? The report said they were using Gemini for things that look like normal IT admin work. That's kind of worrying.
Yeah, it is. It's not always clear what they're up to, but using Gemini to help with Active Directory commands or fix problems with network tools, that could be a way for them to move around inside a network they've already hacked. Something to watch out for.
North Korea seems to be all over the place, from researching infrastructure to writing cover letters for their IT workers.
Yeah, they're interesting. They were looking into free hosting providers, cryptocurrency tech, operational technology systems, even South Korean nuclear technology, and they were using AI image generation tools too. And get this, they were even using Gemini to write work proposals and cover letters, probably to help them get their IT guys into Western companies under fake identities.
What about the information operations groups from China and Russia? How are they using Gemini?
Mostly for general research, writing content, translating stuff, and seeing if they could use AI chatbots for propaganda. And there's this pro-Russia group, CopyCop. They were probably using LLMs to rewrite real news articles to push their agenda.
So the bad guys are definitely playing around with AI, but it doesn't seem like they're using it for super advanced attacks just yet. But this Google report shows just how important it is to stay ahead of them to keep improving our AI defenses.
Definitely. It's a snapshot of what's happening right now, and it tells us we need to be proactive to keep adapting our security strategies as things change.
Okay, so to really understand how these attacks work and how to stop them, sometimes you got to think like the enemy, right? That's where offensive prompt injection comes in. We looked at a course that focused on that.
Yeah, and it's a cool approach. If you want to build good defenses, you need to know how to attack. This course is all about teaching people how to design, attack, and defend simple LLM applications, all through prompt injection.
And it starts with the basics, LLMs, prompts, the attack surface. What are some of the key things people need to know?
Well, understanding how LLMs break down text into tokens, the limitations of the context window, which is how much info the AI can handle at once, and then those emergent abilities, those surprising things that pop up as the models get bigger and learn from more data, that's all fundamental. And the attack surface, that's basically anywhere a bad guy could get in and mess with the LLM, and the prompt interface, that's the main target.
And prompt injection, that's where someone tries to trick the AI into doing something it shouldn't, right?
Exactly. It can be direct, where they put bad instructions right into the prompt, or indirect, where they hide those instructions in data the AI is supposed to process, like a document in a RAG system. The problem is the AI doesn't know what's good and what's bad, it just processes everything. That's the vulnerability.
The course also goes into prompt leaking and data exfiltration. What are some of the ways attackers do that?
Well, prompt leaking. That's all about getting secret info out of the LLM, stuff that's part of its context. Things like hidden system prompts, configuration details, even private data. Attackers can try to ask the model directly for that info, trick it into revealing it with clever instructions, or even exploit debugging features. It's all about finding ways to make the LLM spill the beans.
And then there's jailbreaking. That's where you try to get around the LLM safety filters. We talked about that a bit earlier.
Yeah, and that's a constant battle. Attackers come up with new tricks, and the LLM providers try to patch them. Classic techniques like pretending to be someone else, using the Dan prompt, do anything now, creating hypothetical scenarios and sneaking stuff in at the beginning of the prompt, those are always being developed and then blocked. Attackers also try to exploit weird quirks in the model, like using translation features or specific encoding schemes to slip through the cracks.
The course also covers something called advanced prompt engineering for hacking. That sounds pretty serious.
It is. It's about using advanced prompting techniques, like zero-shot, one-shot, and few-shot prompting, to get the LLM to do something bad. Like few-shot prompting is where you give the AI a bunch of examples of the bad output you want, and it learns from that. And they also use fake roles and personalities to manipulate the model.
And like with any kind of hacking, automation is a big part of it now.
Oh, yeah. Attackers are using fuzzing. That's where they automatically create and test tons of different prompts to see what works. And there are frameworks like Garak, which is specifically designed to find vulnerabilities in LLMs. It's getting pretty advanced.
Of course, the course also teaches people how to defend against these attacks. What are some of the main strategies?
Well, there's prompt hardening, which is making your initial instructions more robust so they're harder to manipulate. Then there's really thorough input sanitization and filtering to catch bad patterns, and output filtering and validation to make sure the responses are okay. Rate limiting can stop brute force attacks. Continuous monitoring keeps an eye on everything, and you can even use multiple LLMs together to create a layered defense.
It's important to remember that this offensive course, it's not about teaching people to do bad things. It's about understanding the vulnerabilities so we can protect ourselves.
Absolutely. The goal is to learn how the attacks work in a safe environment so we can make our AI systems more secure.
So looking at everything we've covered today, what are the biggest risks and vulnerabilities in AI security?
Well, we've seen that AI systems, they can be accessed without permission, and the data they use can be manipulated. Training data can be compromised. Sensitive info can leak out through prompts or the model's responses. Where you deploy your AI system matters a lot, and the models themselves can be tricked during inference through things like prompt injection and jailbreaking. And the whole supply chain of AI models, that's a risk too. You never know if a model you download has a hidden backdoor or some other flaw.
So what are some things our listeners can do right now to be more secure?
First of all, be aware of the risks. Prompt injection especially, that's something everyone should know about. If you're developing or deploying AI, make sure you're handling data carefully and have strong access controls right from the start. Talk to your AI vendors, ask them what they're doing to address these vulnerabilities, and build a multi-layered defense like we talked about in the offensive course.
Wow, this has been a real deep dive into AI security. It's a fast-moving field, and it's only going to get more important.
No doubt about it. AI is getting more powerful all the time, and so are the people who want to misuse it. So here's a question for you, our listeners. How can you stay ahead of the curve? How can you keep learning and adapting your approach to AI security in this ever-changing landscape?
That's a good question to think about.
Yeah.
And if you want to learn more about all this stuff, we really recommend checking out the SANS draft, the Google report, and the OS resources we talked about today. There's a lot more detail in there if you're interested.
Thanks for joining us on this deep dive.
And thank you for listening to The Deep Dive.